This is the launchpad. If you're here, that means you have a rocket design that's ready for field testing. Before we begin, know that there is no shame in using a rocket that you didn't create yourself, provided that you know how to fly it all the same. That's what we're going to learn today, how to fly your rocket. We'll begin by getting familiar with the three most crucial elements of your heads-up display: the navball, the altimeter, and the staging interface. The navball is the big blue globe at the bottom of the screen. Its sole purpose is to indicate the orientation of your vehicle. In other words, where are you pointing? Which way are you facing? At the moment, there isn't much to observe since we're quite firmly planted on the ground. The nose of the rocket can only point straight up. We'll revisit the navball once we take flight. Now look at the top of the screen where you'll find a 6-digit numerical display. This is the altimeter, which indicates the vessel's current elevation, specifically the pilot's elevation. The altimeter has two modes, which can be toggled by clicking the icon to the left of the numerical display. Toggling blue will display your altitude relative to sea level, while toggling green displays your altitude relative to the ground beneath you. Finally, look towards the bottom left portion of the screen for a set of orange tabs with numerical labels. This is the staging interface. Like a caterpillar transforming into a butterfly, your rocket shall too transform throughout its life cycle. Therefore, the staging interface tells you exactly what happens at each transition point. Hovering the mouse cursor over the gray icons within the orange tabs will visually highlight a corresponding component on the rocket. This highlighted component is what gets activated upon transitioning to that stage. For example, as we can see here, the rocket engine is highlighted in green when I mouse over the gray icon under the orange tab for stage 3. That means that transitioning to stage 3 will fire the engine and send the rocket into the air. Hovering over the gray icon under the stage 0 tab highlights the parachute in green. That means that transitioning to stage 0 will release the parachute. Keep in mind that stages advance in reverse numerical order, so in this case, 3, 2, 1, and finally 0. Now we are ready to learn to fly the rocket, starting with the controls. Spacebar will advance the rocket's next stage. Remember, reverse numerical order, therefore stage 3 is up first, and thus we have liftoff. To steer the rocket, the WASD keys are used. In case you're not familiar with the WASD control scheme, imagine those 4 keys like the arrow keys, 4 directions. As you manipulate the rocket's in-flight direction, you'll notice that the navball at the bottom of the screen is now jostling around. You'll also notice how the navball has an orange half that was previously unseen. The crosshair in the center of the navball indicates where the nose of your vessel is pointed. When it's in the blue, your vessel is pointed in the general direction of the sky, away from the center of the planet. When it's in the orange, your vessel is pointed towards the general direction of the ground. Meaning, if the navball is totally blue, like it was before we took off, it means the rocket is pointed straight up. If the navball is totally orange, then the opposite is true, you'd be pointed directly down. And if the navball is half and half, the rocket is sideways, parallel to the ground. It is advised to rely on the navball to orient the rocket rather than looking at the rocket itself. The HUD camera angle can be deceptive and is vulnerable to human error, but the navball never lies. Finally, try manipulating the E and Q keys. If WASD is set to control pitch and yaw, E and Q correspond to roll. The next control you absolutely need to know is M, which toggles the planetary view. Hold the right mouse button to reposition the camera angle and use the scroll wheel to zoom. Locate your rocket and notice the blue parabolic arc with the AP tag on it. This blue arc, as you might have guessed, is your rocket's current trajectory. The AP stands for apoapsis, which is also called apogee when referring to the Earth, or aphelion when referring to the Sun. Apoapsis is the highest point of your trajectory. After passing the apoapsis, our rocket is on a path to descent. To avoid crashing and dying, this rocket has been pre-installed with certain countermeasures, which we can see by hitting spacebar to advance to the next stage. We jettison our depleted engine and fuel, reducing the vessel's weight. Now pay attention to the green number at the top of the nav ball. This is our velocimeter, which indicates how fast we are hurtling through the air, or space. Clearly, we need to reduce our speed in order to achieve a safe landing. The next stage of this rocket will enable the release of a drogue parachute, which is configured to activate at an atmospheric pressure level found at approximately 20 kilometers above sea level. Notice how our velocity starts to plummet as the partially deployed drogue parachute does its work. Finally, after slowing down to even safer levels, we can advance the rocket to its final stage and release our landing parachute, which slows our descent to a crawl. A word of wisdom regarding parachutes. Keep in mind that deploying them too early while falling too quickly will only result in them being torn off due to excessive drag. It's best to try and get yourself into a safe and shallow re-entry angle so that your rocket has plenty of time to slow down purely due to atmospheric drag before deploying any parachutes. But if that's not an option, consider using drogue parachutes to slow down long before releasing your final landing parachute.